Okay, so we're going to look at logarithms in this one. Now, all logarithms is instead of writing it with the base of a number, so for example 2 to the power 3, which is equal to 8, we're going to write it out in terms of the power. So then we'll say log with the base 2 of 8 is 3. What that means is if you take the log of something, you get the power back. So if you had, say, log 10 of 1,000, okay, 1,000, whoa, what is that? 1,000 has 3 zeros, so that's 10 to the power 3. So we get the power back, which is a 3. So that's all a logarithm really is. So that means we can rewrite any notation just by knowing what the base is, which is there, in terms of a log. Alright, so A. Express 3 to the power 4 equals 81 as a logarithm statement. So 3 to the power 4 equals to 81. We first write log. Our base is now 3. The number we want to take the log of is 81. And the power of that is 4. B. Express log of 7 of 1 over 49 equals to negative 2. So our bases are 7, our power is a negative 2. Remember, that's always a power, whatever it's equal to, which is the same as 1 over 49. C. Solve the equation 10 to the power of x equals to 128, expressing the exponent x to two significant figures. What you would do is you would rewrite it first. So we would have log 10 of 12.8 equals to x. Then we need to type it into the calculator, which I will do in a separate slide in a moment. And then you just simply write in the answer after that. So I'll add the answer on the actual slide. D. Solve the equation log 5x equals to 2 for x. So you would rewrite it back the other way. 5 to the power 2 is equal to x. X is then equal to 25. Alright, so on the previous bit we wrote down that log 10 of 12.8 is equal to x, so we needed to find x. So let me clear all this out. What we would do first is we need to write in log. Now if you look on keyboard, there's actually a log function right here. There's also a log 10 one because it's the most common one. There is another one called log ln, which is for something called the natural number. We'll come back to that later time, not right now, but that's something else that you might want to know for later. Okay, so we want log 10, and then you just write 12.8 in there, then we get the answer. Now, I'm obviously in standard view, so I need to convert it using the decimal function, so I get 1.107. You can alternatively use the other one. It will pop up with two different spots. Some people like this more, it's up to you. Write down the base inside, then type in the actual numbers in there. So you notice you get the same answer. Similar to index laws, we have log laws. Now all of these are actually just a rearrangement of the log laws. So for example, this first one, a to the power of 0 is a 1. So if you rewrote it out, you get log of a of 1 is equal to 0. Same with this one, a to the power of 1 is equal to a, etc. These other ones I can do the same thing to find them, but just be careful with them if you just plan on using them. Now, if you add the logs, not inside, outside the logs, note that the plus is separate to the actual logs, you get log a of m times n. If you subtract them, obviously you're doing the opposite thing, so you divide them. This looks a bit funny, I'll just rewrite this. I might rewrite this law because it looks weird. Log a of m to the power of n is equal to n times log a of m, or in other words, n log a bracket n m. Sorry, I know they use p's, but this looks a little bit funny, so I'll just rewrite it out. So I want you guys to keep in mind that there is a special condition of logs. Log of a negative number, so where x is greater than 0, log of a negative number does not exist, because you cannot have a number with a negative in it, and so unless this number here is already negative. But if that number is not negative, you cannot actually have the log of a number being negative. The reason for that is, let's say if log a of negative x is equal to b, if you rewrite this out, we have a to the power of b giving you negative x. Now what can you think of where if you take the power of, that gives you a negative here? It doesn't make sense, right? Because there isn't any. Well, there is one, but you're not going to learn about it unless you're doing special. So the special condition here that you have to remember is the log of a number, whatever that number is inside the log, cannot be negative. So just keep that in mind. Okay, so simplify the following using the log laws. Alright, we have log 10 of 5 plus log 10 of 2. Remember, if you're adding them, you multiply the numbers inside, so you get log 10 of 5 times 2, which gives us log 10 of 10. Remember, log, if the base and the numbers are the same, that's just to the power of 1, because that's your power. Remember, log finds your power. Okay, log 2 of 80 minus log 2 of 5. So we divide the 2, so then we get a 16. Then that's to the power of 4, so the answer will be a 4. Log 3 of 2a to the power of 4 plus 2 log 3 square root of a over 2. Okay, so best way to do this is to rewrite the second one with the log law first, so that we actually have, so we get rid of the power. Now this one over here is a over 2 to the power of a half, but then you have a 2 outside, which you then multiply as well. So that means those two cancel out. That's the reason why I said it's best to actually just simplify in terms of one single log first. So then we have 2a to the power of 4 times, these two cancel out, so we're left with a over 2. 2's cancel out, so we're left with log 3 a to the power of 5. Now normally we just write a number outside the log by convention, so we get 5 log 3 bracket a. D. Now we need to actually simplify this using powers first, and remember this divide sign, this divide sign here actually does not mean you divide inside, just remember that. So then we have log a. Now if I write this in terms of powers of 2, it's a fraction, so you get a negative, and then 4 is 2 squared, so we get negative 2. But then we can take the power down. So then you notice you have log a of 2 and log a of 2, they cancel out, so we're left with a negative 2. Alright, so these two are going to be calculator based, so I'm just going to use a calculator to do one at a time. I'm going to do a first on this one. Okay, so we're at 5 to the power of x equals to 8. All we simply really need to do is use the solve function. Then 5 to the power of x is equal to 8, and tell it to solve for x. Then you might notice if you have the exact values there in log, just convert it so you get 1.29. Alright, so these two are going to be calculator based, so I'm just going to use a calculator to do one at a time. I'm going to do a first on this one. Okay, so the last little bit, we want to solve the equation written here. Simply put it all in terms of one log first. So we have log 6 of x minus 1 equals to 1. Then we just need to rewrite the equations. So we have x squared minus x. We'll simplify the numbers inside the log first. Rewrite it so that we have 6 to the power of 1 there. 6 to the power of 1 is a 6, so we'll just rearrange it and then solve for x as per usual. So then we have x minus 3, x plus 2, so x is equal to 3 or negative 2. But keep in mind that log of a number can't be negative. The reason for that is you have to think about if you can have any power giving you changing a number to be negative. There isn't one. So that means x is equal to 3. So just keep in mind of that condition.